Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about engineering tribology subject. So in this, today, as a part of engineering tribology, so we will discuss about model paper 1 questions related to this corrosion topic. So the model paper questions, first one is explain briefly about the factors influence the corrosion. So what are the factors influencing the corrosion? We have to explain briefly. So the factors affecting the rate of corrosion, there are some factors affecting on the corrosion. So the rate and extent of corrosion mainly depends upon the nature of metal, nature of environment. Two things. So the corrosion mainly depends upon these two only, the nature of metal and the nature of environment. So the factors affecting the rate of corrosion, the nature of metal and nature of environment. What is this? The difference between these two? One is purity of the metal is available in the nature of metal, and then here nature of environment temperature. In second point, physical state of metal. In this humidity in air. Then third one, the nature of metal case, nature of oxide film affecting the rate of corrosion. In this nature of environment, effect of pH value. The corrosion rate depends upon this pH value. The position of metal in galvanic series. The conductance of the corroding medium in the case of nature of environment. The relative areas of anode and cathode in the case of nature of metal. And then presence of suspended particles, impurities in our atmosphere. So nature of metal, the solubility of the product of corrosion, and then amount of oxygen in atmosphere. So electrode potentials are required in nature of metal. So these are the factors affecting rate of corrosion. That depends upon the nature of metal and nature of environment. The factors due to nature of metal are clearly given here. The purity of metal. So what is this purity of metal? The heterogeneity of the metal is due to the presence of impurities which form tiny electrochemical cells at the exposed parts. So the anodic parts get corroded. The second point is electrode potentials. Metals with higher reduction potentials do not corrode easily. They are noble metals like gold, platinum and silver. Whereas the metals with lower reduction potentials readily undergo corrosion. The examples are zinc, magnesium, aluminum, etc. These are examples for electrode potentials. Next, position of metal in a galvanic series. So metals which possess low reduction potentials and occupy higher end of galvanic series undergo corrosion easily. The metals which possesses high reduction potentials and occupy lower end of galvanic series do not undergo corrosion and they get protected. So when two metals are in electrical contact in presence of an electrolyte, in the case of electrochemical corrosion, when the metal which is more active undergoes corrosion, So the rate of corrosion depends on the difference in their position in galvanic series. Greater the difference, more will be the extent of the corrosion at anode. So this point is very important. The greater the difference, it gives more will be the extent of corrosion at anode. The position of metal in galvanic series depends upon the difference in their position. Next, relative areas of anodic and cathodic cells. The relative areas of corrosion is influenced by cathodic to anodic cells. If the metal has a small anodic and a large cathodic area, the rate of corrosion is very high. This is because the electrons are liberated at anode, which is consumed at cathode. If the cathodic area is larger, the liberated electrons are rapidly consumed at cathode. This further enhances the anodic reaction, leading to increase the rate of corrosion. Physical state of metal. Metals with small grain size have more tendencies to undergo corrosion. Metal with more stress or strain also undergoes corrosion easily. So, nature of surface film, the metal oxide layer. If the corrosion product formed is more stable, insoluble, and non-porous, it acts as a protective layer and prevents further corrosion. So, examples: tin, aluminum, and chromium. If the corrosion product is porous, volatile, and soluble, it further enhances the corrosion. That is ferrous, zinc, and magnesium. Factors due to nature of an environment. So one is temperature. The rate of corrosion reactions increases with increase in temperature. Similarly, humidity in air. The moisture and humidity present in atmosphere furnishes water to the electrolyte, which is essential for setting up of electrochemical cell. The oxide film formed has the tendency to absorb moisture, where creates another electrochemical cell. So the humidity in air, suppose present in the atmospheric air, so here the oxide film formed has the tendency to absorb moisture. So that is creates another electrochemical cell. Next, pH value. The pH value of the medium has the greater effect on corrosion. Acidic pH increases the rate of corrosion. Similarly, presence of impurities. So all these points comes under this nature of atmosphere. What we have discussed in comparison table. In this, we have discussed nature of environment depends upon the temperature, humidity in air, and effect of pH value. So we have already discussed about these three. So next we will see conductance of the corroding medium, and then suspended particles, impurities in atmosphere, and amount of oxygen in atmosphere. All these topics for humidity in air. Next, presence of impurities. The atmosphere is contaminated with gases like CO2, SO2, H2S, the fumes of H2SO4, HCl, etc., and other suspended particles in the density of industrial areas. They are responsible for electrical conductivity, thereby increasing corrosion. Next, amount of oxygen in atmosphere. So, as the percentage of oxygen in atmosphere increases, the rate of corrosion also increases due to the formation of oxygen concentration cell. The decay of metal occurs at the anodic part and the cathodic part of the metal is protected. So, as the percentage of oxygen in atmosphere increases, the rate of corrosion also increases due to this formation of oxygen concentration cell. Next, corrosion control methods. So, electrochemical protection or cathodic protection. The principle involved in the electrochemical protection or cathodic protection is to force the metal to behave like a cathode. So, the question is, explain about corrosion control methods. So, one is there are two types of cathodic protection. One is sacrificial anodic protection, another one is impressed current cathodic protection. In the case of sacrificial anodic protection, in this method, the metallic structure to be protected to behave like a cathode by connecting it with more active metal. So that is called as anodic metal. So that all the corrosion will concentrate only on the active metal. So the artificially made anode thus gradually gets corroded, protecting the original metallic structure. So hence this process is otherwise known as sacrificial anodic protection. Aluminium, zinc, magnesium are used as sacrificial anodes. So here in this diagram, the sacrificial anode and the pipeline that is cathode. So one is at this sacrificial anode, the reaction is oxidation, and at this reduction. So whenever the electrons flows from one sacrificial anodes to pipeline cathode. So this is one is magnesium and another one is ferrous. In sacrificial anode protection, what happened? The metallic structure to be protected. It behave like a cathode. So here it is connecting with the anode. So here the protecting material is here iron, the pipeline. So protected from the corrosion. This is connected to the sacrificial anode. So this one is acted as a anode, and this one pipeline is acted as a cathode. So sacrificial anode protection diagram shown in this slide. So these are the important applications of this method. Protection of underground cables and pipeline from soil corrosion. So one is underground cables and pipelines from soil corrosion. Next, important application of this method of protection of ships and boat hulls from marine corrosion. Ships and boat hull. So here sacrificial anode protection. This is protected base metal shown here, the sacrificial anode, and the protected base metal, this one. So the important application of this method are prevention of rusty water by inserting magnesium sheets or rods into domestic water boilers or tanks. In boilers or tanks, rusty water by inserting magnesium sheets. Rods are into domestic water boilers and tanks. So impressed current cathodic protection. In this method, an impressed current is applied in the opposite direction of the corrosion. opposite direction of the corrosion current to nullify it, and the corroding metal is converted from anode to cathode. This can be done by connecting negative terminal of the battery to the metallic structure. To be protected, the positive terminal of the battery is connected to an inner anode. The inner anodes used for this purpose are graphite platinized titanium. So impressed current cathodic protection shown in this diagram. So in this method, the impressed current is applied in the opposite direction of the corrosion. So a corrosion current. See here, the source of current, a anode and a cathode. So the black fill and then a graphite is anode and insulated copper wire and pipeline shown in this diagram. So this is protected pipeline. So in this also the protected one is acted as a cathode, but this is the impressed current. So that is the current, the corrosion, the applied current in the opposite direction of the corrosion current. Next, impressed current cathodic protection shown diagram. The rectifier drives the corrosion current to simulate the anode corroding. So this is actually protected one pipeline. The impressed current diagram you can observe in this slide. So the anode is buried in a backfill containing mixture of gypsum, coke, breeze or sodium sulfate. So the backfill provides good electrical contact to anode. The containing mixture of gypsum and coke, all these things, to provides a good electrical contact to anode. So the pipeline, which one is to be protected, is connected to the anode. This is graphite and then a backfill gypsum. The ground level shown in this. So the backfill provides a good electrical contact to anode. The impressed current cathodic protection applications are structures like tanks, pipelines, transmission line towers, underground water pipelines, oil lines, ships, etc. can be protected this method. So the structures like tanks, pipelines and transmission lines, towers. And pipelines also protected by using this method, impressed current cathodic protection. So these are the methods used for this protection from the corrosion. So in examination, sometimes they will ask, so what is the difference between these two methods, anodic protection and cathodic protection methods? And also, so they will ask like this, rather neat sketch for the impressed current cathodic protection and explain briefly. Similarly, for this sacrificial anodic protection, explain briefly with a neat sketch about sacrificial anodic protection. So you have to give explanation with this diagram in the examination. So how many control methods are there? So explain briefly. So sometimes they will ask. So these are the applications and methods explained in this session. And these are the references I have taken. So you can select any textbook and go through for other explanation or for other information. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.